Hi, this is jbedord. Today I'm going to introduce you to citation searching and analysis. It builds on the searching that you have been doing so far using keyword and subject searching. Citation searching is based on human behavior. First of all, scientific discoveries do not develop in a vacuum. Scientists are always building on previous work. In the process of documenting this previous work, a researcher will cite the work of others. So by looking at the references of individual authors, subject experts can be identified, then their research traced forward and backward. The technique we'll be using is called citation chaining. It's the foundation of scholarly research. You've probably already used backward chaining by mining the references at the end of articles you've found using keyword searching or subject headings. Now we're going to look at forward chaining by identifying articles which cite the article that you have found. This type of analysis utilizes specialized databases called citation indexes. There's also sideways chaining, which identifies similar articles because they share some of the same references. The assumption is that these experts are playing in the same space, even though they aren't citing each other directly, usually because they're doing work at the same time. The beauty of this approach is that your research is not dependent on vocabularies. Once you have found the perfect, or even the not so perfect paper, you can follow the citations to find similar research in that subject area. Even if the terminology changes, you'll still be able to find relevant papers by tracing the authors. Let's start with the basics. You are all familiar with the metadata for bibliographic citations, with title, author, and publication being the most important fields. This metadata is unique to the work. It's quite complete and the foundation for getting the full text, particularly if you need images and figures. In many types of articles, particularly scholarly publications, there's an additional set of citations at the end of the work. These are sometimes called references, sometimes works cited, or bibliographies or endnotes. These citations are much briefer and often cryptic with abbreviated titles and journal names. Sometimes they're fielded separately and sometimes just mushed together into a general text field. It's these references at the end of the paper that we'll be examining in this unit. The Institute of Scientific Information, known as ISI, created the first citation databases in the early 1960s and published them as print indexes. As online technology evolved, these indexes became much more useful as linking was added. There are 3 databases, each with their list of covered journals. The best known is Science Citation Index, also known as SciSearch. Then there is the Social Sciences Citation Index and the Arts and Humanities Index. Originally, ISI licensed these individual databases to online aggregators. Later, ISI was bought by Thomson Reuters and developed its own service, first called Web of Knowledge, now called Web of Science. You will be using the core collection, so we'll be searching across all 3 databases. Web of Science also has additional databases, but these are searched separately. 2 of the citation databases are available on ProQuest Dialog, and you'll be exploring them in this module. ISI still licenses these databases directly to the academic libraries, so they're readily accessible to scholarly researchers. Due to budgetary considerations, a library may not license all of the databases, and they may also limit the time depth. In the process of citation chaining, you will find that other databases have been added linking. There are links to authors that you can identify other work that they have done. There are links by journals so that you can find articles that are being published in a general area. None of these are perfect, so you'll find yourself meandering through the citations to find the gems you're looking for. As you search the ISI databases, be aware that there are biases in the way these indexes are constructed. First of all, there are a limited number of journals included in the databases. This means the coverage is not comprehensive, though there is some research indicating that about 80% of citations do come from articles in these journals. Book bibliographies are not included in the core collection, though there is a separate database. The strength of the ISI databases is in the scientific, technical, engineering, and medical area, or STEM. These disciplines rely primarily on journals for scholarly publication, and with coverage dating back to the early 1900s. However, outside this area, other disciplines such as history rely more on books and monographs. In the area of arts and humanities, there really isn't an equivalent for creative works. And then in education and business, these are also poorly covered, so that other methods are used in these areas. So far, we've talked about the professional search engines. But there's another widely used search engine for citation analysis is Google Scholar. It's actually quite useful as a complement to the commercial search services, particularly since it is free, at least for now. There's no advertising to pay the bills, so no one knows whether it will be supported indefinitely. In contrast to the ISI databases, which have a significant human element in selecting the journals and creating the databases, Google Scholar is totally algorithmic. As a researcher, I'd like to have a better idea of the journal coverage at the time depth, information that professional search engines can provide. Another issue is that the search engines keep changing, and that affects information retrieval. So Google Scholar is a great additional resource, but should not be regarded as comprehensive. This module would not be complete without mentioning the controversial area of analysis for scholarly production. The author citation report identifies articles that an author has written and the citations to those articles by other authors. But the same data is also used to calculate the impact factor, which is the number of times articles from a particular journal are cited in scholarly papers. It's essentially a proxy for the importance of a journal in scientific literature. These impact factors are then used to rank and compare journals and their influence. Given the biases of the ISI methodology and the evolution of new publishing venues, there's been a movement to define alternative measures, particularly in the arts and humanities. These have been dubbed altmetrics. Adoption of new approaches is slow in academia, so altmetrics may be utilized in addition to traditional measures. There are a lot of different aspects to the issue of scholarly production, so this is simply an introduction to the concepts. Don't worry about the details of the calculations at this point. Time to move on to actual searching. These concepts will make more sense when you actually use them. So let's go exploring citation chaining.